Question 10. The equation x squared plus m minus 3 times by x plus m equals 0 has two real and distinct roots. Determine the range of values for m. So when you see the statement here, real and distinct roots, you should be thinking about the discriminant. So when something has real and distinct roots, that means b squared minus 4ac is going to be greater than 0. Okay, so knowing this, we can now go on to solve the question and figure out what the answers are. Okay, so we'll write down the original expression, which is x squared plus m minus 3 x plus m equals 0. Okay, and we're looking for the coefficients here, which are usually written in the form of ax squared plus bx plus c. So our coefficients here are a is 1, b equals m minus 3, and c equals m. So now we can plug this information back into our expression for the discriminant. So b squared, we can just go ahead and do it straight away, I think. M minus 3 squared minus 4 times a, which is 1, times c, which is m, is going to be greater than 0. So m squared minus 6m plus 9 minus 4m is greater than 0. So m squared minus 6 and 4m go minus 10, m plus 9 is going to be greater than 0. Now we want to factorize this expression. So what times this together to make 9 but adds together to make negative 10? Well, it's going to be negative 1 and negative 9. So m minus 9 and m minus 1 greater than 0. So the roots here are 9 and 1. Okay, but we're asked to determine the range of the values for m. So that's saying, for what range of values of m will this statement be true? So if we sketch a graph, we're told here that m squared minus 10, m plus 9 is greater than 0. So because of this positive m squared, we know that it's going to have a minimum, right? And we know that the roots occur at 9 and 1. Okay, and for the real and distinct roots, we need to have our value greater than 0. So whenever this is above the x-axis, whatever values of m are above the x-axis, that's going to give us the range of our values. So basically, for any number that m is less than 1, it's going to be positive or above the x-axis, and for any value of m that's greater than 9, that's going to give us our positive values over there. But anything in between these would give negative values, which would make this statement untrue, therefore they aren't included in the range. Okay, so where do you get the marks for this question? Well, you get a mark for using the discriminant here. You get a mark for finding the roots here, and you get a mark for applying the condition that it needs to be greater, that your quadratic expression needs to be greater than 0, and you also get a mark for determining the range and also including that with a sketch.